Welcome to this course on SOAR Community Playbooks. In this course, we'll examine community playbooks that are available automatically with your SOAR server and how to enable these playbooks to automatically analyze new events. Before you take this course, you should be familiar with basic SOAR concepts, which you can learn in the Introduction to Splunk SOAR training course. Our objectives are to learn to identify community playbooks that can be applied to our use cases, to find playbooks that use our local security tools, and to enable these playbooks in our SOAR server. Our course will cover an introduction to community playbooks, discovering community playbooks, and enabling community playbooks on our SOAR server. Topic 1. Introducing SOAR Community Playbooks. SOAR can automatically respond to new events. A playbook is a set of instructions for SOAR to use to determine the correct response to the new event. Splunk provides pre-written community playbooks for immediate use in new SOAR implementations. When an event is loaded during ingestion, the data is loaded as is, but sometimes that data is not particularly descriptive. For instance, in this event for a suspicious file download, we have information in the event's raw artifacts about the event's request URL and source domain, and we have the downloaded file's file name and file hash. So it would be useful to find out some information about the source domain location and the file that has been downloaded. So we may want to automatically run one or more playbooks that will enrich the artifact data with more meaningful information. Community playbooks are provided by Splunk, and they're built into your SOAR server. They're accessible from the community repo, and they cannot be modified. New versions are created frequently. Make sure you have the latest version. Playbooks can perform practically any task, but in general, think about 4 main features of playbooks. They can gather and/or enhance information in an event. They can make decisions on further actions based on that information. They can perform actions outside of SOAR to respond to the event, and they can update the event with results of actions and change the event status. Playbooks can also notify staff, request input, and call other playbooks to perform other tasks. As an example of a playbook, it could first gather information about a new downloaded file, and then gather additional information about the reputation of the source, and then also information about potential malware in the file. Then, based on the results of that information gathered, it could alert the Security Operations Center staff, stop processes started by the file, and delete the file. Topic 2. Discovering SOAR Community Playbooks. All playbooks are managed on the Playbooks page in SOAR, which you can get to from the main menu by selecting Playbooks. Here you can search and filter tools to search playbooks by name, description, by app, and by action. You can also use the update command to make sure you have the latest playbooks. The community repo, which is short for repository, is a GitHub read-only distribution point for Splunk SOAR playbooks. Your SOAR server also has its own built-in local repo. And you can also use research.splunk.com to learn more about playbooks. To access playbooks, navigate to Playbooks on the main menu. On the Playbook Management page, each playbook is shown on its own line, and each column header supports filtering for the values in that column. For instance, on the repo column, we can filter for playbooks that are either in the community repo or in the local repo. Now our view is filtered so only playbooks in the community repo are shown. Before we start searching for SOAR community playbooks that we can utilize, it's important to make sure that we're looking at the very latest versions of these playbooks. And we can do that by using the Update from Source Control option at the top right corner of the screen. Clicking on this will allow us to choose which repo to update, and our case, there's only the community repo available. And then we can choose the update option. This will connect to the SOAR community repo at GitHub and verify that all of the versions of our playbooks are updated to the latest version, and also that we have downloaded any new versions. In this case, everything on our server is up to date. Now, using text filtering, we can search for words that are in the playbook name. For instance, I can search for reputation, since we know we're interested already in learning more about the reputation of the source of the downloaded file, and I can see that there are several results. The apps column is particularly useful here. It shows the apps required by each playbook. Your SOAR administrator will configure app assets for any security tools or services your company has access to. You can only use the playbooks that you have apps for. As an example, let's say we have two apps we have configured, VirusTotal v3 and PhishTank, and we want to see what community playbooks are available that use those two apps. We can search for them on the apps column, and we can see some results, but only two playbooks in our case use only those two apps. In this case, it's the PhishTank URL Reputation Analysis playbook and the VirusTotal v3 Identifier Reputation Analysis playbook. The other playbooks require other apps that we may not currently have access to. For our scenario, a very useful resource for researching playbooks is the research.splunk.com site, and using the Explorer button in the Playbooks section to access a list of playbooks in the community that are available and allow us to drill down into them for additional information for their intended purpose and how to enable them. As an example, the Dynamic Identifier Reputation playbook is a good starting point for adding detailed information to new events. You may also notice in the type column that these playbooks are broken down into categories of investigation and response. The Dynamic Identifier Reputation Analysis playbook is identified as investigation. However, notice that there is also a Delete Detected Files playbook identified here, which could actually become the next stage in our activation of playbooks. Let's examine the Dynamic Identifier Reputation Analysis playbook by clicking on its name. Here we're giving a lot of information about how to implement this playbook. We're shown a diagram of the playbook, and in fact we can open it up in a dynamic explorer that allows us to select the various tasks that are activated within the playbook and examine what they actually do. In the viewer, we can use controls at the bottom left corner to enlarge the playbook, and we can click and drag the background of the playbook to move around. Then we can click on the blocks to open up a detailed information view in the top right corner that explains the action for each block. And we can see here the first thing we check is to see if there are artifacts in the event. And if there are, we will continue on with the green path. But if not, we'll simply add a comment to the event and we'll move on. If we do have artifacts, we first filter for the appropriate types of artifacts, and then we call a sub-playbook Dispatch Reputation Playbooks, which will actually call the sub-playbooks that will perform all the actions. Once those playbooks are complete, we can then gather the results and attach them to the event, and then this playbook is complete. Topic 3. Enabling SOAR Community Playbooks. First, make local copies of the playbooks. This is not always required, but in this case, these playbooks that we have chosen to implement must be local to run correctly. Then make sure the apps and assets used by both playbooks are enabled. To do this, we need to determine the playbook apps and assets and make sure that these are configured with assets matching each asset name in the playbook. Configuring apps sometimes means getting a license or user account. If an app is already configured but the asset name does not match the asset names expected in the playbook, you have one of two choices. Either make a new asset for the source server that has the same name as the asset used already in the playbook, or make a local copy of the community playbook and change the asset name in the playbook to match the locally configured asset. To do this, we'll work with both apps and assets, and this is configured on the main menu in the Apps page. For our scenario, we need assets for PhishTank, which is automatically enabled for all source servers, and also for VirusTotal v3. The VirusTotal v3 app requires an account at the VirusTotal website, so we'll need to configure that. When we're ready to enable our playbooks, we can run them in several different ways. First off, we can change a playbook status to active. Active playbooks will execute when an event is added or if the event's artifacts are modified or if new artifacts are added to an event. Playbooks can also be run manually from an event's page, and this is very useful for testing. Finally, playbooks can be executed as a step in a workbook. To make local copies of community playbooks, we'll open them in edit mode. For instance, the PhishTank URL Reputation Analysis playbook. We'll click the name. This will open the playbook in the editor. And then we will immediately choose the Save button and select the local repo to make our saved copy. We'll also have to put in a comment for the reason why this was saved, so we'll just say Make Local Copy. And click Save. I can then close this tab for the editor, and I can repeat the process for the VirusTotal Reputation Analysis playbook. And click Save. Now, if I search for playbooks in the local repo, I'll see that there are only the two that I just created. Making these playbooks local was necessary in this particular scenario because the reputation analysis dispatch playbook is looking only for local versions of these playbooks. Now we need to deal with the apps and assets that must be configured for these two playbooks. If we look at the apps and assets columns, we see that we use the PhishTank app with an asset named PhishTank, all lowercase, and VirusTotal v3 with an asset named VirusTotal v3, including an underscore. So these apps need to exist on this machine. We can use the main menu to navigate to the apps page. And on the apps page, we can see that the PhishTank app is already configured with one asset, and it is named PhishTank, all lowercase. Well, that's exactly what we need. However, there is no VirusTotal app. So if we search for VirusTotal, we'll see that there are two unconfigured apps, VirusTotal and VirusTotal v3. Version 3 is the one that we want. So we'll configure a new asset, and we'll name it, as expected by the playbook, VirusTotal underscore v3. In asset settings, we do require a VirusTotal API key. To get our API key, we'll need to go to the VirusTotal website. The VirusTotal homepage will require a login, and if you don't already have an account, you can create a free account at this site for testing purposes. Once you've logged in with your account, you can click the profile icon and select API key. You can then click the Copy API Key button to copy your personal API key. You can then bring that copy back to the asset configuration page and paste it in. Click Save. You can then click the Test Connectivity button to check to make sure that you've correctly configured this asset. If we see Connectivity Test Passed, then it has been successful. While we're on the Apps Management page, we should point out also that you can find associated playbooks for each app. That is, for instance, let's take the MaxMind app as an example. I can click on the associated Playbooks link, and I'll get a table of all playbooks that use that particular app. This is similar for searching on the Playbooks page. It just gives us the ability to do this from the apps page as well. So here we can see that there are 3 playbooks that use the VirusTotal v3 app. There's one that we have not used yet, the Domain Investigate playbook, but then there's the one from the community repo, and then the one that we created in our local repository, all of which are using this app. Now that we've configured our VirusTotal and PhishTank apps and assets, and we've made local copies of our playbooks, we can go to our sample event, and then we can use the Run Playbook button to execute our playbook manually. We can search for its name and locate the Dynamic Identifier Reputation Analysis playbook. And we'll execute this playbook, making sure that it is set to execute on all artifacts, and then we'll choose Run Playbook. We'll see activity in the activity panel as the steps in the playbook are executed. And then we can see that we executed the Dynamic Identifier Reputation playbook, and it in turn called the Dispatch Input Playbooks playbook, and it in turn executed our VirusTotal v3 Identifier Reputation playbook and our PhishTank URL reputation analysis. And each of the actions that these playbooks took is shown in the Activities panel. Output from the results of the actions that were executed is displayed in the Widgets section in the lower part of the Events page. However, you can get more details about the results coming back from each of these actions by drilling down into the detailed action results for each action. In the Activities panel, you can click on any of the action names, such as the VirusTotal v3 URL reputation action, and this will open up a detailed panel which includes the full JSON output from the action. It's usually useful to look at the summary information first. We can see here in this case for the URL reputation, VirusTotal found 68 harmless reports, 2 malicious reports. If we do the same thing for the domain reputation, again we can examine the output from that for the summary, and again we can see primarily harmless output. Then finally for the file hash reputation action, we'll expand those results, and in the summary information we can see that there actually were 54 reports of malicious nature for this particular file hash. So we do indeed have malware here. At this point, a Security Operations Center analyst would take this information and use it to guide their further actions. In the future, we could also enable more SOAR community playbooks that would do such things as delete the file and turn off any processes started by the file. Another way to run playbooks is by using them inside of a workbook. A workbook is a checklist that Security Operations Center analysts can use to respond to an event. I'll add a workbook to this event for self-replicating malware, and then I'm going to edit this workbook and add a new task. I'll call it Run Analysis, and I'll configure it to execute our playbook. I'll save these changes, and then I'll close the playbook editor. Now that this is a step in our workbook, I can select the task, I can assign it to myself as the owner, I'll start the task, and then I can execute the playbook simply by clicking its name. The playbook will execute in the background, And if I look at the activity page, I can see that it has executed. But also in my workbook, I can see that it has created a note for its output. And the note generated in the workbook output by this playbook is quite useful in that it goes through each of the type of objects that have been analyzed for their reputation and then gives them a normalized score where the URL is shown to be lean safe and the domain is known to be very safe. However, the hash value is known to be malicious. So this will give you another way to execute the playbook and immediately see a summarized version of the output that brings all the information together in one place for decision making. If we've decided that this playbook should always be executed on all new events, then we can return to the playbook management page. We can select our playbook, and we can change its status from inactive to active. This playbook is designed to look for events with any label, so it will execute as soon as any event is created. It will look for the artifacts that it knows how to analyze for reputation, and then it will leave the action results in the event for later analysis. This is the first step towards completely automating this process. In the future, we could design new versions of these playbooks that would automatically take mitigation action, like deleting the file and eliminating its processes, as well as other actions. This concludes this course on enabling SOAR community playbooks, but you may want to learn more. If you want to find out more about the basics of Splunk SOAR, like events, artifacts, cases, and so forth, then the Investigating Incidents with Splunk SOAR course is for you. The Administering Splunk SOAR course will give you additional in-depth details about apps and assets, actions, and many more aspects about setting up and running a SOAR server. The Developing Splunk SOAR Playbooks course will give you in-depth training on playbook design, creation, and testing. And then the Splunk SOAR Advanced Implementation course will give you very intensive training on custom coding in SOAR, integration with Splunk ES, and many more advanced topics. Thank you for attending this course.